Okay, so this is going to be a review of some of the questions from the Unit 2 review. I'm going to start with number 4. It says sketch the graph of the derivative of the function shown. So they give us this function here, and they're asking us to sketch the derivative. All right, so the first thing I'm going to notice is where the function is increasing and decreasing. If it's increasing, then the derivative has to be above the x-axis. If it's decreasing, the derivative has to be below the x-axis. Also, if it has a horizontal tangent line, it needs to touch the x-axis because that means the slope is 0. So first, I'm going to notice that it's increasing from -2 to 2. So that must be above the x-axis, and it's decreasing from -infinity to -2 and 2 to infinity. There's a horizontal tangent line. At x equals 0, so my graph of the derivative must touch the x-axis. And then the other thing I'm going to note is from -infinity to -2 and from 2 to infinity, those are lines, which means they have a constant slope. So I can see that the slope from -infinity to -2 is -1. So the graph of the derivative should look like the constant line y equals -1. From 2 to infinity, it is going down 2 and over 1. So that means it's going to have a slope of a -2. So the graph should look like y equals -2. All right, so first thing, let's just notice where it is increasing. Well, I can see on this graph right here and this graph right here, it is not above the x-axis from -2 to 2. It's partially on the first one, but it's not on the second one at all. All right, so that leaves me with the last two. But they have a graph of y equals 1 and y equals 2 for part C. It is -1 and -2 for part D. So my answer is D. All right, next question says find all the values of x where the tangent line is horizontal. All right, I know that lines that are horizontal have a slope of exactly 0. And I know that when I take the derivative, that gives me the slope. So I'm going to take my derivative and set it equal to the slope of a horizontal tangent line or horizontal line, which is 0. So the derivative is 6x squared plus 72x plus 210. I set that equal to 0, and then I'm going to factor because I want to solve for x. I think I can factor out a 6. That gives me an x squared plus 12x plus 210 divided by 6 is 35. And that factors as x plus 7, x plus 5. So x equals -7 and -5. All right, the next question asks me the total cost in hundreds, so make sure we remember that that's in hundreds, to produce X units of a product is C of X equals 2X minus 9 over 4X plus 7. Find the average cost for each of the following production levels. All right, for part A, if I want to find the average cost, I'm just going to find the cost of 30 units and divide it by 30 units. So I have C of 30 is equal to 2 times 30 minus 9 over 4 times 30 plus 7. So I have a 51 divided by 127. So that is the cost of 30 units. So if I want to find the average cost, I'm going to divide it by that 30 units. So 51 divided by 127 divided by 30. And that gives me approximately 0.134. All right. But they told us that that was in hundreds, so I need to multiply that by 100 and I get 1.34. The next is part B, is to find when there's X amount of units. So we're going to do the exact same thing, right? What we did was we plugged in 30 and then we divided by 30. Well, to find the average cost function, I'm going to take my cost function and divide it by the number of units, which is X. So I have 2x minus 9 over 4x plus 7 divided by x. Well, x is the same thing as x over 1, multiply by the reciprocal, and I get 1 over x. So I get 2x minus 9 over x times 4x plus 7. All right, then the next one is find the marginal average cost function. All right, if I want to find the marginal cost, I take the derivative. So let me erase this. What I'm going to do is go ahead and distribute the x in that denominator so that I have a 4x squared plus 7. That way, I don't have to use the product rule in the denominator. So I want to find the derivative of my average cost. I'm going to take the derivative of the top times the bottom minus the top times the derivative of the bottom. And the derivative of 4x squared plus 7 is just 8x. Oops, I forgot to distribute that x to that 7. Sorry. So that is I'm out of room. All right. So I have an 8x plus 7 divided by the denominator squared. So 4x squared plus 7x squared. All right, and that's it. Next question, use the information given in the figure to find the following items. All right, so what we have here is we have the graph, the dark blue line or the navy blue line, that is the graph of our function. And then what they've done is they have given us the tangent line at this point 1, 2, so that we know what's going on in that graph. And that's that purple line is that tangent line. So first of all, it says find f of 1. So f of 1 tells me the y value at 1. So that is 2. Part B says f prime of 1. All right, well, at f prime of 1, what I'm going to need to do is I'm going to need to find the slope of the tangent line at that point. So it looks like I have a rise 1, run 2, rise 1, run 2. So that means my slope is 1/2 is the slope of that tangent line, which means f prime of 1 is 1/2. The domain of f, -2, including -2 to infinity. And then the range, it starts at 0 and it goes off to infinity. All right, and that's it. All right, question 32. Find the equation of the tangent line to the graph of the given function at the given value of x. All right, so we want to find the equation of the tangent line at x equals 2. So here's our function. I have a function times a function. Now we definitely don't want to multiply that out 9 times. So we're going to have to use the chain rule on that part, but we're also going to have to use the product rule because I have a function times a function. So the derivative, the first is going to be 4x. The second is going to be the x squared minus 4x plus 5 to the ninth. All right, so the derivative of the first, the derivative of 4x is 4 times the second, which is x squared minus 4x plus 5, plus the first, 4x, times the derivative of the second. We're going to use the chain rule or the extended power rule. You bring the 9 down, subtract 1 from the exponent, then take the derivative of the inside. The derivative of the inside, so the inside is x squared minus 4x plus 5. The derivative is 2x minus 4. All right, and that is going to give us the slope of the tangent line. So I'm going to plug in 2 here without simplifying. So I have a 4 times 2 squared minus 4 times 2 plus 5. And notice that if I plug in a 2 here, I get a 4 minus 4, which gives me 0. So this whole next term is just equal to 0. All right, and I have a 4 minus 8, which is a negative 4 plus 5. So I get a 4 times 1, which is 4. So my slope is 4. I'm going to plug into y equals mx plus b. I need to figure out what my y value is at 2. So 4 times 2, 2 squared minus 4 times 2 plus 5. And I think we already figured out that that was 1 to the ninth. And I get a 4 times 2, which is 8, times 1, which is 8. So my point is at 2, 8. So if I plug into y equals mx plus b, 8 equals slope, which is 4x, which is 2, plus b, which means b is equal to 0. So the equation of my tangent line is y equals 4x. Right, next question. Find the derivative of the following function. All right, so we have a fraction. So I'm going to use the quotient rule. So the derivative of the top is going to be 8 times 4, which is 32, e to the 8x, times the bottom, 5x plus 2, minus the top, 4e to the 8x, times the derivative of the bottom, which is just 5, all over 5x plus 2 squared, over the bottom squared. And you can leave it just like that. Since it's not asking you to find like the slope of the tangent line or find the horizontal tangent line, you can leave it exactly like that. All right, another derivative. Find the derivative of this function. So we're going to have to use the chain rule for the numerator, but we're also going to use the quotient rule. All right, so the derivative of the top, we're going to use the chain rule. So I'm going to bring down the 6, 7t minus 5, subtract 1 from the exponent, times the derivative of the inside, which is 7. I'm going to just put that out in the front. Then times the bottom, 3t squared plus 2, minus the top, 7t minus 5 to the 6th, times the derivative of the bottom. The derivative of 3t squared plus 2 is just 6t. All over the denominator squared. So 3t squared plus 2 squared. That's it. All right, another find the derivative. So just a reminder, if I'm taking the derivative of e to some function, the derivative is the derivative of that exponent times just the original function. So what I need to do on this problem is find the derivative of that exponent and then just multiply it by the original function. I'm going to rewrite it so that it is e to the x 5x minus 14 to the 1/2. All right, I'm going to have to use the product rule to find that derivative. All right, so the derivative of the first is 1 times the second, 5x minus 14 to the 1/2, plus the first times the derivative of the second. Bring the 1/2 down, chain rule, 5x minus 14, subtract 1 from the exponent. So the original exponent is 1/2. Subtract 1 and I get negative 1/2, times the derivative of the inside. And the inside is 5x minus 14, so the derivative of that is 5. Now, we're going to multiply this by our original function, the original exponential. Make sure you put these in brackets or parentheses, because if I don't do that, then it's only the last term that would be multiplied by that exponential function. All right, next question. We need to find the derivative of this logarithm. So let's just note a couple things. So first, if I have a base to the x, then the derivative of that is the natural log of that base times that original function. All right. Also, if I have log base b of some function, then the derivative of that is the derivative of the inside over natural log of b times the inside. All right, so what we need to do is we need to do this part right here, the derivative of the inside over natural log of b over the inside. And to do that, we have to take the derivative of the 6 to the p. All right, so the derivative of that 6 to the p is equal to natural log of 6 times 6 to the p. All right, now in the bottom, we have to take natural log of the base. The base of our log was 5. So natural log of 5 over times just the inside, which in our case was 6p minus 4. All right. All right, so this is a chain rule question. They give you some values on a graph, and we have to come up with the correct value. So it says find the derivative of f composed with g and evaluate it at 2. So remember, if I have f of g of x, or f composed with g, of x, then the derivative of that is f prime of g of x times g prime of x. So if we want to evaluate that at 2, I want f prime of g of 2, g prime of 2. So first I'm going to find g of 2. So I'm going to go to the 2 column. G of 2 is 2. So I have f prime of 2. G prime of 2 is 2/9. Now I need f prime of 2, which is negative 3. So I get negative 3 times 2/9, which is equal to negative 2/3. All right, now we want to do the same thing, except for it's g composed with f of x. And the derivative of that is going to be g prime of f of x, f prime of x. And we are asked to evaluate that at 1. So I need g prime of f of 1, f prime of 1. So I'm going to find the 1 column, and f of 1 is 3. F prime of 1 is -1. And now I need g prime of 3. So I'm going to go to the 3 column and find g prime, which is 8/9. So I get 8/9 times -1, which gives me a -8/9. Next question. It says, suppose that the graph below is the graph of f prime of x. All right, so f prime of x is not the graph of the function, it's the graph of the derivative. Find the open intervals where f of x is increasing or decreasing. So if I look at here at my graph of my derivative, anywhere it's above the x-axis is increasing, anywhere below the x-axis is decreasing. So it's increasing from -infinity to -6, from -2 to 2, and 6 to infinity. And then it's below the x-axis and decreasing between -6 and -2, and 2 to 6. And notice I should probably take out these union signs because they tell us in the directions to separate them by commas. So it says use commas to separate the answers. So let's use commas, that way they don't count wrong for using unions. All right, next question. For the function below, find the critical numbers, the open intervals where the function is increasing, and the open intervals where it is decreasing. All right, so to find the critical numbers, I take the derivative and set it equal to 0. So f prime of x is equal to 12x minus 18x minus 120. And I'm going to set that equal to 0. I think I can factor out a 6. And I get, oops, that should be squared. I get a 2x minus 2x squared minus 3x minus 20. All right, and I need to factor that. I'm going to use the AC method. So I have a 2 times 20, which is 40. So let's see. I have a 10 and a 4. I have an 8 and a 5. 8 and a 5, I think will do it. So I have 2x squared minus 8x plus 5x minus 20. Now we factor by grouping, factor out a 2x, and I get an x minus 4, factor out a 5, and an x minus 4 again. So now I can factor out my x minus 4, 2x plus 5. So I get x equals 4 and -2/5. Whoops, -5/2. All right, now I'm going to take those numbers and put them on a number line and see where my derivative is positive and where it is negative. So I'm going to choose something less than -5/2. Let's say -10. If I plug in a -10, I'm going to get a negative number times a negative number, which gives me something positive. I'm going to plug in a number between -5/2 and 4. Let's say 0. I'm going to get a negative number times a positive number, which gives me something negative. And then lastly, I'm going to plug in something bigger than 4, let's say 5. I get a positive number times a positive number, so I get something positive. So I know it's increasing from negative infinity to negative 5/2 and 4 to infinity, and it's decreasing from negative 5/2 to 4. And I believe that's all they want on that question. All right, next question. Again, they want us to find the critical numbers, the open intervals of the function is increasing, and the open intervals where the function is decreasing. So the first thing that we need to note on this function is it is not defined at x equals -3. In fact, there is a vertical asymptote. So that cannot be one of my critical numbers. We will include it on our number line, but it is not one of our critical numbers because it's not in the domain of our function. So let's go ahead and take our derivative. So the derivative of the top is 1 times the bottom plus, whoops, not plus, minus the top times the derivative of the bottom. And the derivative of the bottom is just 1 over the bottom squared. So on the top, what I end up getting is a -5 over an x plus 3 squared. If I set this equal to 0, you will find that you can't actually come up with a value for x where this is true. So there are no critical numbers. Now, if I want to decide where it's increasing or decreasing, I'm still going to include where it's undefined, all right? So I'm still going to include my vertical asymptote. So I'm still going to include -3 because it could change from increasing to decreasing or decreasing to increasing there. So, but if you notice, if you look at our derivative, the bottom is always positive and I have a negative sign. So it's going to be decreasing everywhere. So the first part is asking where the critical numbers are. We found no critical numbers. The second part is where it's increasing. Well, it's not increasing, only decreasing. And then it asks us where it's decreasing. So negative infinity to -3, and then -3 to infinity. And that's it. All right, next question. Find the equation of the tangent line at the given point on the following curve. So what we have here is we have a equation that we're going to have to differentiate implicitly. So let's start with the derivative of the left side. So the natural log of x plus y. So I'm going to take the derivative of the inside, which is 1 plus dy dx over the inside, x plus y, equals, now I want the derivative of the first term on the left side, but notice I'm going to have to use the product rule because I have a function times a function. So the derivative of the first, which is 4x, times the second, y squared, plus the first, 2x squared, times the derivative of the second, 2y dy dx, plus, now this one's only in terms of x, so the derivative of the inside is 2x over the inside, x squared plus 1. Now they want us to find the equation of the tangent line at the point 1, 1. So the slope of that tangent line is going to be dy dx, the derivative, when I plug in that point. So I'm just going to change dy dx to my slope and plug in my point. So I have a 1 plus m over 1 plus 1 equals 4 plus 4 times m plus 2 over 2. So this is 1/2 plus 1/2 m equals 4. Well, let's see, that 2 over 2 is 1, so we get a 5 plus 4m. I'm going to put everything with an m on the right and everything without an m on the left. So I have a 1/2 minus 5 equals a 4m minus 1/2 m. And 1/2 minus 5 is going to give me -10, -9/2. And 4m minus 1/2, that's going to give me a 7/2 m. And then if we divide, so I have m equals -9/2 divided by 7/2. Fraction within a fraction, we can't keep that, so we multiply by the reciprocal, and I get a -9/7. So that's my slope. I'm going to plug in to my y equals mx plus b. Y is 1, my slope is -9/7. My b is 1, my x is 1 plus b. So I have a 1 plus 9/7. 7 plus 9 is 16. So I get a 16 over 7. So the equation of my tangent line is y equals -9/7 x plus 16 over 7. All right, last question. A 16-foot ladder is leaning against a building. If the bottom of the ladder is leaning along the pavement directly away from the building at 3 feet per second, how fast is the top of the ladder moving down when the foot of the ladder is 2 feet from the wall? So I'm going to attempt to draw a picture. Here's the wall, and here's my ladder. All right, they tell me that the ladder is 16 feet tall, and it is sliding along the pavement away from the building. So it's sliding this way, which means the top of the ladder is sliding that way. So the first question is always, what are they asking for? So they want to know how fast is the top of the ladder moving down, all right? So let's label this side X and this side Y. So we are looking for dy dt. Then we want to write down what we know. We know that dx dt, right, the speed that it's going away from the building is 3. And that is when the ladder is 2 feet away from the wall. So it is 3 feet per second when x is equal to 2. So the next part is we need to model what's going on in the picture, right? So we have a right triangle, so we're going to use the Pythagorean theorem. X squared plus y squared equals 16 squared. So you just make a note that the length of the ladder does not change in this equation, right? The length of the ladder in this situation stays the same, so I can leave it as a constant inside my model. The third part is to take the derivative. So I have a 2x dx dt plus 2y dy dt equals 0. All right, and now we're ready to plug in. However, we do not know what y is, but we can find y. Since x equals 2, and I know the hypotenuse is 16, then I can figure out what y is when x equals 2, right? So 2 squared plus y squared equals 16 squared. So I have a 16 squared minus 4 gives me 252. So y squared equals the square root of 252. I don't think that is a square root that we know. So let's just leave it as 252 until we get to the very end of our problem, because it probably tells us it does round to the nearest thousandth as needed. All right, so I'm going to plug in now. So I have 2 times x, which is 2, dx dt, which is 3, plus 2 times y, which is the square root of 252, dy dt, which is what we're looking for, equals 0. So I have 2 square roots of 252, dy dt equals negative 24, and dy dt equals a negative 12 over square roots of 252. And I'll plug that in, 12 divided by second square root 252. I'm getting a 0.7559, but it looks like that is not what we got. So let's try this one more time. Make sure I got everything correct. Square root of 252, good. 4 times 3, which is, there we go. 4 times 3 is 12. So that would make this 6. All right, so 6 divided by 252. And that gives me approximately negative 0.378. All right, so that's it for the review questions. Good luck studying. We'll finish up the last lecture 24 on Monday and start reviewing. Remember, the exam is on Wednesday. All right, have a good weekend, guys.